You know, when you watch a superstar athlete, you have to wonder what really separates them from the rest of us. We always talk about speed, strength, all the physical stuff. But what if their biggest advantage, their real secret weapon, is something you can't even see, something happening deep inside their brain's visual system? All right, to get our heads around this, let's start with a question that sounds more like a brain teaser. Imagine you need to mail a letter. Easy, right? Now imagine you can't consciously see the mail slot. You have no idea what angle it's at. How on earth could you get that letter in? It feels totally impossible. But solving this little puzzle is the key to understanding what makes an elite athlete tick. And to solve it, we're not starting on a sports field. We're going to look at a real-life medical mystery, the truly fascinating case of a patient known to science simply as JS. His story is incredible, and it completely changed how we think about vision. Okay, so get this. Here's the paradox with JS. If you showed him a slot and asked him, hey, is that vertical, horizontal, diagonal? He'd have no clue. His answers were total guesswork. He was, for all intents and purposes, consciously blind to the slot's orientation. But then you hand him a letter and say, go ahead and post that. And like magic, his hand moves, rotates the letter perfectly, and slides it right in without any hesitation. His conscious perception was gone, but his ability to act was perfect. How was that possible? Well, what was going on is that JS had a condition called visual form agnosia. A stroke had damaged a very specific part of his brain, the part responsible for recognizing what objects are. But, and this is the crucial part, the stroke left other parts of his visual system completely untouched. And that gave scientists this incredibly rare window into how our vision is actually built. So the fact that one piece of his vision could be broken while another worked perfectly led to this groundbreaking idea, the dual stream theory. It turns out we don't just have one single visual system. We basically have two, operating in parallel, and each one has a completely different job. First, you've got the ventral stream. You can call this the what pathway. Think of it like the team's scout. Its whole job is to identify things in the world. That's a baseball, that's a defender, that's the goal, and figure out what it all means based on your memories. This was the system that was damaged in patient JS. His scout was offline, which is why he couldn't tell you what he was looking at. But JS still had his dorsal stream, the how pathway. This is the star player. This system doesn't care what something is, it only cares about where it is and how to interact with it right now. It calculates location, angle, and speed in real time to guide your body. It's the system that knew exactly how to orient his hand to post that letter, no conscious thought required. Okay, so let's bring this all back to sports. Because this same exact setup, these two distinct visual systems, isn't just a clinical curiosity. It is the fundamental playbook running behind the scenes of every single great athletic achievement. So here's the bottom line. Elite performance isn't about just having a good scout or just having a good player. It's about how flawlessly those two work together. It's a seamless partnership, a constant conversation between recognizing the situation and executing the action. Think about something like catching a fly ball. The moment the ball leaves the bat, your ventral stream, the scout, says, okay, that's a baseball, high in the air, I need to catch it. But from that millisecond on, the dorsal stream, your star player, takes over. It's calculating the arc, the speed, it's telling your legs where to run, your arm where to reach, and it's shaping your hand perfectly to meet the ball at the exact right time and place. Now, for a long time, the thinking was that these two streams were pretty separate, each doing its own thing. But this is where the science gets even cooler. We now know they are in constant communication, talking to each other. And hey, don't just take my word for it. Research, like this 2015 study, makes it crystal clear. The evidence shows that these streams are absolutely not independent. They interact. And that crosstalk is the secret sauce for making incredibly fast, precise decisions under pressure. And this isn't just a vague idea. We're talking about actual physical wiring in the brain. Scientists have mapped out these superhighways of white matter, pathways with names like the vertical occipital fasciculus that act like fiber optic cables, carrying information back and forth between the what and how systems at unbelievable speeds. And that brings us to the final and most important piece of this whole puzzle. What really makes a pro isn't just how good each pathway is on its own, it's the quality of the connection between them. So let's finish our analogy. If you've got the scout in the booth and the player on the field, these connections, these white matter pathways, are like the coach's headset. They are the crystal clear, instantaneous communication line that lets the scout's knowledge guide the player's action in real time. And this is where the magic really happens. That constant, high-speed chatter between perception and action is what allows an athlete to just react. It transforms conscious knowledge into pure split-second instinct. They don't have to think, they just do, because their brain is wired for it.
So it leaves you with this final thought. Next time you see an athlete do something that looks impossible, are you just watching a physical marvel? Or are you really seeing the result of a perfectly tuned, lightning-fast conversation happening deep inside their brain?